Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts for our upcoming CSIR NET and the GATE Physics exam. So we will be discussing all those important points here in the session, and I hope that today's session will be helping you all to take your preparation to a very good level. And if in case anywhere if you will be having any doubt, you can surely let me know about it, and we will try to consider all these important points here in this session today. If there will be anything not getting clear to you, you can just comment about it and let me know about it. And if everything will be getting clear to you, then that's great. So guys, I'm going to start the mathematical physics discussion in this session today. And yeah, important concepts, questions, and the points we will be taking. I'm going to show you some important slides first of all, and after that we will be continuing the discussion. This is about the community feature on the Unacademy learning app we are going to have, which will be helping you to do the best preparation under the guidance of top educators, even to get the information or the details about the latest updates. So this is how, guys, the community feature will be helping you. Other than this, we are going to have the Unacademy Iconic and Unacademy Plus, both the subscriptions available on the Unacademy learning app, which will be helping you to take your preparation to the next level. What are the benefits you will get if you will be taking the iconic subscription have been shown here on the screen. Even guys, we are going to have the notes available on the learning app too. So you will be able to do the best preparation with these important notes as well as all the details which have been shown here. You can use and apply the referral code that's Anjali Live as mentioned here on the screen to get the discount in the total subscription amount. This is about the plus subscription, and even in upcoming days so many new courses by the top educators will be starting on Unacademy. So if you don't want to miss important courses and the classes by the top educators, then you can start your preparation under the guidance of top educators now. This is about the light subscription, and we are going to have the another one which is going to clearly show you the difference between the plus, iconic, and the light subscription. So that's how, guys, you can just decide which one you want to take, whether you want to go for the plus, iconic, or the light subscription. And depending on whichever you find more beneficial for you, you can take that subscription and take your preparation to the another level or a very good level under the guidance of top educators, because everything you will be getting there after taking the subscription will be helping you to take your preparation to a very good level, even to prepare important concepts, questions, and many important things. So this is how everything will be helping you, guys. But in case if there is anywhere you are gonna have doubt, surely mention it. I'll be talking about that point, okay? And if everything is clear, let's go ahead with the discussion, and let me just share the more important details with all of you. So the first one we are going to talk about is the important topics of mathematical physics which you should not miss and you should try to cover up, okay? So what are these topics and how the mathematical physics portion can be very much helpful and can help you to score good marks in the exam? All that even I will be covering here in the session right now. So actually, guys, even if you will check the question paper we are gonna have, which we had like 1 year ago, okay, or which was there 2 years ago, or which was there 5 years ago, which was there 8 years ago. So if you will see it's the random number I have mentioned here. If you will see the previous year questions, you will be finding that there we are going to have the topics from where the mathematical physics questions have been asked. Either it will be metrics based, okay, like it's a major portion, means in most of the years, in most of the question papers, we are having those questions to be there. So metrics based questions are there. Other than that, we are going to have the you can say contour integration based questions there, okay. Or if I'm going to talk about the next one, that's going to be the complex analysis based questions will be there, okay. Other than that, if we will talk about the next one, that's going to be yours metrics, contour integration, complex analysis, and the next one Laplace transform. Taylor series, differential equation, and numerical techniques like the Simpson's one-third rule, the trapezoidal rule, the Newton-Raphson method, all of that. Okay. Now guys, these are the most popular topics we are going to have. Even sometimes from the vector sections we had the questions. But if we will talk about the most popular ones and from where we had the questions most of the times in the exam. So these are the topics we had. Okay. Now the point is, okay, so how we can score good marks with mathematical physics? Basically, when you prepare mathematical physics topics, you will find there is not so much means unlimited portion. No, it's just the finite portion we are having. We just need to focus on, we just need to prepare it. And that's how we can easily solve any question based on these topics. We can easily consider any of these questions. Okay, it will not be difficult for us to work on them then. So I hope you're gonna get it, guys, that metrics, contour integration, complex analysis, Laplace transform, Taylor series, differential equation, numerical techniques or vectors, any of these topics based questions you can expect in your upcoming exam, and all these are quite simple and easy topics as well as easy to prepare. So if you will be considering these topics like step by step and you are going to cover them up within 5 days or 8 days, your major portion of mathematical physics will get done and you will be ready to work on most of the questions from the previous years or even in your upcoming exam. Now what we will do, we are just going to take some questions from the previous years right now and we will be observing that what type of questions have been asked, and even some different cases based questions will be taking here, so which are going to have some condition or situation present there which we need to consider and we need to be extra careful about that part. So that's what we will talk about here. Here is the first question we are going to have. It's x cube in the denominator. I'll be giving you some time to work on it. If you will be getting the right answer, you can mention it in the comments. Otherwise, I'm going to continue the discussion and going to let you know that what you have to do and how you can consider the steps to solve it, how you can get the answer for any such type of questions quickly, easily and in less time. So all that we will be discussing in the session today, but I'm gonna wait for your reply by giving you some time. Otherwise, step by step I'll be talking about each and everything about this topic and the question we are doing right now. So the principal value of the integral, that is integration minus infinity to plus infinity sine 2x upon x cube dx, is, remember, in your syllabus at this point of time is the contour integration, so you don't have to consider just the normal integration to solve it. So that's what is the first thing you need to keep in mind. Now giving you some time to work on this question and to let you think about it, like what steps you can take and how you can proceed further to solve it. But if in case there will be anything not getting clear to you or anywhere you will be having doubt, we will surely go ahead with the discussion and we will be talking about that part then. So this is a question from the contour integration. Next thing. In this question, what we have to do, integration negative infinity to plus infinity we are going to have. We can write it to be imaginary part of integration minus infinity to plus infinity okay, e to the power iota. Either I can write 2x or I can write 2z, both are correct. But if I will write z, I have to consider all the terms in terms of z. So I'm keeping it x right now, okay. Otherwise, if I'm keeping the z in the power, I have to write the z in the denominator and here as well. But right now I'm just keeping it same. Now, if we are going to talk about the next thing here, that's going to be, you know that e to the power iota theta is equal to cos theta plus iota sine theta, where cos theta is the real part of it and sine theta is the imaginary part of it. So in this case, what will happen? In this case, the sine theta is nothing but it is the imaginary part of e to the power iota theta, as you can see. Now in this case, what you have to do, you have to consider e to the power iota 2x is equal to 1 plus iota 2x, okay, plus iota 2x square divided by factorial 2 and plus so on 2. So what I'm going to do by doing this or by taking the expansion of exponential. So actually in this case, we are going to try to use the formula to find the residue, as per which we are going to have, let's say, if x is equal to a is a pole, okay, so in that case x minus a we consider as t, and then we say the coefficient of 1 upon t is what? That's the pole, the residue at that particular pole, okay. The pole was x is equal to a, so coefficient of 1 upon t you have to just search for. Now it is the method of finding the residue which is applicable for the simple pole as well as the pole of order n, means where n is the greater than 1 value. So in this case, if you will see, you are just going to have x is equal to a, x minus a is equal to t, and coefficient of 1 upon t is the residue. So what is the pole first of all? What is the a value here? So pole is nothing but it is just the finite value of the term, the function, okay, at which the function becomes infinity. So that is going to be what? X is equal to 0 in our case. X is equal to 0 is the finite value where the function is becoming infinity, okay. If you will put x is equal to 0, you can see it is present in the denominator, so your function will become infinity there. Now what next? The next thing is, once you're going to consider this part, you have to take care of this thing, that x minus 0 you will consider as t, then a coefficient of 1 upon t will be the residue, which means 1 upon x, because a is 0 here. So for that case, I'm going to write the exponential series expansion as I have shown you. In the denominator, I will have is the x cube. And in the third term, you can see I'll be getting 1 upon x. And 2 will get cancelled out. So I'll be having the negative 2, okay, just present there, okay. That is my residue. So residue is what? It's going to be negative 2. And also the integration is nothing but in this case, since your pole was purely real and your integration limits were negative infinity to plus infinity, so in this case it's going to be pi iota into sum of residue, which is negative 2. So pi iota with negative 2 gives you this, but you know your answer will be nothing but the imaginary part of it. So what is the imaginary part? Just negative 2 pi. This is what you will get. That's it. You got the final answer for it then. So that's your option A, which is the correct one. Now, I would like to tell you something about it. If in case instead of sine you will have the cos present there, you have to call it the real part of the exponential function. And the only thing is that you will only consider these parts, or it can help you to do the simplification in the cases when you are having the integration limits given to you as negative infinity to plus infinity. So you have to take care of two parts. One is the limit, another one is sine or cos. If they are in the numerator, for any such type of case, you can write them as the real or the imaginary part depending on what is present there, and that's how it can help you to make the calculation quite simple and easy for you. You can tell me if there is something not getting clear to you or somewhere there is any doubt. We can talk about it then. And if everything is clear, let's go for the next question, guys. Let me just write it on the screen. But if there will be anybody having any question, query or doubt, you can surely let me know. Okay, one fact based question. let's talk about it. So it is going to be, which of the following cannot be the eigenvalues of a real 3 by 3 order matrix? Okay, so which of the following cannot be the eigenvalues of a real 3 by 3 order matrix? Now to answer this question, you need to know one thing, that either either there should be all the real values you can have, or if there will be any imaginary value, in that case imaginary along with 0 you can have, but the complex conjugate of the imaginary term should also be present there. Okay, so in the pair they will be present the imaginary part with its complex conjugate term and the 0, right? And either all, or we, in these cases we can have purely real values. Okay, so if you will see, the option B is showing you all the purely real, imaginary, its complex conjugate, and 0. So it is also possible imaginary or the iota there, its complex conjugate, and purely real or the 1. But in this case, like 0 or 1, like it can be any of these one, but whenever imaginary is there, its complex conjugate must be present. Okay, like in A and C, but here its complex conjugate is not present. So in that case, for any real matrix, if there is imaginary term present, its complex conjugate must be there. If it is not there, then in that case it is not going to be the possible kind of eigenvalue for any real matrix. Hence option D is going to be the correct one. Please tell me if in case there is anybody having any doubt, we can talk about it. But if it is getting clear to you, I think anytime whenever you will solve any such type of question, it will be quite simple and easy for you to consider the right answer. Now the next one is here, let u x y is equal to e to the power. Okay, I'll be writing it here. This is from the complex analysis part, guys, the one I'll be writing now. Excuse me. The function fz is a complex analytic everywhere, is a complex analytic everywhere in the complex plane if and only if in the complex plane if and only if and only if the options are b is equal to 0. I'm just going to write it here on the screen. B is equal to plus minus a, and C option is B is equal to plus minus 2 pi a, and option D is B is equal to a plus minus 2 pi. Okay, this is how we will be considering it. So let uxy is equal to e to the power ax cos by be the real part of a function which is fz is equal to uxy plus iota vxy of the complex variable z is equal to x plus iota y, where a and b are the real constants and a is non-zero. The function fz is a complex analytic everywhere in the complex plane if and only if what. So they are saying it will be analytic everywhere if and only if what. So in that case, what are the conditions corresponding to the analytic function we know and which can help us to work on either only if we are having the real part or the imaginary part of the function given to us. So that is, if there is any analytic function, its real or the imaginary parts will be satisfying the harmonic function condition. And what is that? That is simply going to be delta to u upon delta x square plus delta to u upon delta y square equal to 0. Okay. Now, next thing. This is the harmonic function condition. Okay. You just have to put u value there, and when you will put the u value, it's going to be a square. It's going to be a square e to the power ax cos by as it is, plus, see, cos differentiation will be negative sign, and then negative sign will give you just the cos. So negative sign there, we will have b square e to the power ax cos by is equal to 0, right? So in this case, what will happen? E to the power ax cos by, e to the power ax cos by. So a square minus b square will be equal to what? It will be equal to 0. Hence, you will be having a is equal to plus minus b, or b is equal to plus minus a. Hence, your answer, that is option B, will be the correct answer. So what we have discussed here, that we can go for the harmonic function condition because that is associated with the analytic function parts, like the real and the imaginary separate parts, and that's how we can just solve it. If in case you're gonna find like something is not getting clear to you or something there you're gonna have any doubt, we can then talk about it. But if everything is clear, then that's great. I'm gonna show you the other slides too, and we'll be giving you the next question after this. But if in case there is anybody having doubt or anything you want to ask, you can surely let me know about it. Just gonna draw it here. It's going to be this way. It's going to be this way. Then you're just gonna draw it this way and this way. Okay. In this case, what will happen? You are going to have this to be negative 1 and this to be positive 1, and here you are going to have the gamma. Now x and y, this is what you will have. Options which are given to you are 0, the next one is 2 pi, and the next one is negative 2 pi, and the next one is just going to be 4 pi iota. So let's see how many of you will be able to get it. If in case there will be any doubt anybody will have, we can then talk about this part, guys. Don't worry, I'll be explaining it to you. But if you are just gonna get it, then that's gonna be great. I'm gonna wait for your reply, and then we will go ahead for more discussion. So just check it out and let me know whether everything is clear to you or not. If there will be any doubt, we can go ahead with the discussion just in some time. Okay, I'll be starting it. So they have given you the function, that is the integration over the closed contour gamma z e to the power iota pi z divided by 2 upon z square minus 1 dz along the closed contour gamma shown in the figure is. So actually in this case, if I will talk about the pole, or like how to find the pole, this part, so you know that you just have to equate the denominator with 0, and when you are going to equate the denominator with 0, you will be getting z is equal to plus minus 1 from there, and both the poles are lying within the contour. Okay, this was the starting step you have to take. Now once you got the poles, you have checked whether the poles are lying within the contour or not. What next? The next thing is that we have to go for the next point. And what is that? That is simply going to be the order of the poles we have to check, and accordingly we will use the formula to find the residue. So if you're going to see this part, guys, look at this. It's going to be what? The power 1 we are having, or you can separately even write it as z minus 1 times z plus 1, and the both terms are having the separate powers to be 1, which shows that its order is 1. Okay, and once you got it, now you have to work on finding the residue. For that we will be using the respective formula. For example, limit z tends to positive 1, first of all, z minus pole, that is 1, and fz. Fz is basically the function, so that is z e to the power iota pi z divided by 2, and next we are going to have is divided by z minus 1 and z plus 1, because that was z square minus 1 we had. Apply the limits now. That's going to be e to the power iota pi divided by 2 upon 2, which is cos pi by 2 plus iota sin pi by 2. Cos pi by 2 is 0, iota sin pi by 2 is 1. So iota divided by 2 we will have. This is what we can consider. Okay. Same way for z tends to minus 1, if we will consider, it's going to be z plus 1 e to the power negative iota pi z divided by 2 we will have, divided by z plus 1 into z minus 1. Just try to cancel out the terms which will get cancelled out. This one is not cancelled. This is written as it is, negative sign 1. Okay, now apply the limit. So when you will apply this one, it's going to be e to the power positive iota pi divided by 2. Actually, when I have taken this e to the power iota pi z, I should write it positive. Without applying the limit, it's not going to become negative. So now I will apply the limit. It will be e to the power negative iota pi by 2 and negative 2 in the denominator. It will give you negative iota in the numerator and the negative 2, which is just iota by 2. But the thing is, if you will see, it is going to have the direction which is what? Which is going to be anti-clockwise. Okay, and this is going to be clockwise if you will take the arrow this side. So in this case, what will happen? This is anti-clockwise, this is clockwise. This will be negative 2 pi iota into sum of residue, and this will be 2 pi iota into sum of residue. So in that case, what will happen? It's going to be 2 pi iota into sum of residue is giving you iota by 2. Okay, then negative 2 pi iota sum of residue with the negative iota by 2, and that's going to be, no, it's even positive you are gonna have, right? Let's check it out. Negative, 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 that's going to be positive, right? If we are just going to write the final steps with the expression and the formula, so we are going to have I'm just going to check out all the steps we have taken. Z minus 1, that's z minus pole, will give us z plus 1. Cancelled out, negative 1 will give you negative 2, e to the power negative iota pi by 2 cos negative iota pi by 2 plus iota sin negative iota pi by 2. So it will be giving you just negative iota and divided by negative 2, which will give you positive 2, right? Yep. So in this case, the positive one is giving you what? The positive value, which is 2 pi iota sum of residue. Guys, I think we are missing some negative value somewhere. Let me just find it out. You can even check it out, like, are you getting it same or something different? E to the power iota pi z divided by 2 in the expression, z minus 1 times z plus 1. Z plus 1 is getting cancelled out. Then I will be applying the limits. E to the power negative iota pi by 2. It will be giving me the negative value as well, which will give me negative and negative to be positive. So for plus and for minus, it must be same. Iota square minus 1, which is minus minus plus. Iota square minus 1. But somewhere some change needs to be done. Let me just recheck all the steps we have taken. Let's do it again. I think there is a correction needs to be done, and that's only we can just catch that point after observing each and every step we are taking there. So for z is equal to 1, when I'm trying to find the residue, it's going to be plus 1 is going to have the direction what? Anti-clockwise. So that will give me 2 pi iota into sum of residue. It's going to be limit z tends to iota, z minus iota, okay, or limit z tends to 1 in this case. So z minus 1, and fz, which is going to be z e to the power iota pi z. Oh, we missed the z there. Got it. We missed the z there. We didn't consider the z. Okay, that's the reason we were not getting it. Now, just apply the limits. It will give you iota by 2. Again, limit again z iota pi z divided by 2, and you are going to have z minus 1 times z plus 1. Just cancel it, negative, and negative will be positive, but negative from the denominator, so it will give you negative iota by 2. This was in anti-clockwise direction, so 2 pi iota into sum of residue, which is iota by 2. This one is in clockwise direction, negative 2 pi iota into sum of residue. That's going to give you this value. 2 cancelled out, iota square is minus 1. So minus minus plus, but again negative you will get, so that is negative 2 pi. Just check out all the steps we have taken and let me know if in case there is any doubt anybody is going to have. Otherwise, this is how you can get the right answer, and this is how you can just simply proceed further to get the answer for any such type of questions. If everything is clear, I'm just going to give you the next question now. So you can see what was the reason for not getting negative in the previous steps, just because we didn't mention z there, right? But when you are going to mention z there, you are getting it to be correct. Next is a random variable n obeys Poisson statistics. The probability of finding n is equal to 0 is 10 to the power negative 6. The expectation value, even guys, probability is one of the topics you can expect the questions from in the upcoming exams, of n is nearest to options are okay. You can try it now, otherwise I'll be telling you the steps you can take to work on this type of question. So the question is a random variable n obeys Poisson statistics. The probability of finding n is equal to 0 is 10 to the power negative 6. The expectation of n, okay, is nearest to. So that is the expectation value of n is nearest to. So what we will do in this case, we will directly be using the formula from the Poisson statistics, and that's how we will be able to get the answer. So I'm gonna wait for your reply to give the answer for this question, and after that, just in some time, I will be continuing the discussion too. I'll be talking about it, that what steps you can take and how you can proceed further to get the answer. So it is a random variable and obeys Poisson statistics. From here we got the idea about the Poisson statistics to be used. But even in case if they will not mention the term Poisson statistics there, then what we will do? The probability of finding n is equal to 0 is 10 to the power negative 6, which means this probability is very much small. Okay, that will be giving us very small value, closer to 0 you can say. The expectation value of n is nearest to. So when you got the probability to be small, you can get the idea that okay, it is something I have to use the Poisson statistics in this question. So when you got this idea, your probability expression is nothing but in this case it will be mu to the power n, that is the mean value to the power n, factorial n, that is how many times you want to get this, e to the power negative mu. Mu is what? That's going to be mean value you want to find. Probability is what? 10 to the power negative 6. And mu is what? The mean. So you want to find it. And n is what? 0. So e to the power negative mu divided by factorial n, that is factorial 0. Now you want to find mu. So you will just have 10 to the power negative 6 is equal to e to the power negative mu. When you will just compare these terms, you can see that exponential, if you will remove, you will get the log base, okay? But to make it equal to 1, the log base 10 should be there, okay? So for that, you have to multiply 2.303. It will give you log base 10, and negative 6 will be remaining there, which you will get from the power in the other side. So this is what you will have. The negative signs you can just simplify, and you are going to have the positive there, which will be giving you approximately 13.8, and that is the mu value, which is a 14. Hence your right answer is nothing but option A. That's how you can get it, and I hope each and everything is getting clear to you guys. But in case if there is anybody having any doubt, we can talk about it then, and we can consider the steps if there is any doubt anybody is gonna have. But if everything is clear, we can go ahead for discussing it more and to talk about the rest of the steps you can take. In terms of arbitrary constants, A and B, Try it now and let me know as you will get it done. In terms of arbitrary constants a and b, the general solution of the differential equation, this given differential equation is what? So first of all, it is important for us to know what kind of differential equation it is. It is going to be the Cauchy-Euler differential equation. As you can see, its coefficient and the order of differentiation both are same. It is power 2 term. It is also having the second order derivative. It is 1 and it is having the first order derivative, right? The power of x is even 1. Here the no x term, hence the differentiation is also not present there. So in this case, what will happen? We will be considering every time you are going to have any such type of question, you will take x d by dx equal to capital D, x square d2 by dx square as d into d minus 1. Okay, and if you will have even x cube d cube y upon dx cube, you will take it to be d minus 1 d minus 2. Like that you will have to consider it. Okay, now let's talk about the next part. What is that? After putting these values, the solution you will write, because it is just a homogeneous second order differential equation as the right hand side is equal to 0. So in that case, your solution will be just the complementary function. So when you are going to consider it, what you will have there, let me just write all the steps for this case so that you will be able to relate like, okay, actually this is what is going to happen here. So you are going to get D multiplied with D minus 1 and then plus 5 times the D plus there is going to be 3, and let's say we have taken y common. So it is giving us d square plus 4d plus 3. 3 ones are 3, 3 plus 1 is 4. That's how you can consider it. So you can write it to be 3 plus 1 d and 3 equal to 0, which will give you d common d plus 3, and then plus there you are also having d plus 3 equal to 0. You are getting d is equal to negative 1 and 3, which are real and unequal values. Hence your solution which you will have will be y is equal to a to the power m1z. Now what is this z? So actually we consider the x is equal to e to the power z, and then you will get the z is equal to log x. Okay, so your equation, because this capital D is nothing but d by dz, but there like how to relate it with the given terms in the equation, that's what we have considered. A e to the power negative z plus, because m1z, that m1 is negative 1, b e to the power m2z, that is 3z, and z is nothing but the log x. So let's write it, a e to the power log x to the power negative 1. I have just removed this negative sign from there, plus b e to the power log x to the power 3. Okay, this is what you will have. So you are going to get a divided by x plus b x to the power 3. Is it positive 3 we are getting? No, negative 3 itself. So this is how we will have negative 3 and x b divided by x cube. This is what you will have. So this is your final answer, a by x plus b by x cube. Now whatever option is showing you the same thing, that's your correct answer you will have. If in case guys there is anybody having any doubt, you can tell me, we can talk about it. But if it is clear, I'll be giving you the next question then. Here's the next question. I'm just going to write it. A 4 by 4 complex matrix A satisfies the relation that is A dagger A is equal to 4i And in this case, we are going to have where I is the 4 by 4 order identity matrix. I is the 4 by 4 order identity matrix. Just a second, guys. We are going to continue. I'll be writing the rest of the part for it. And then we will talk about the steps we have to take to solve it. Okay, just give me a second. Okay, I hope each and everything is clear, but in case if there is any doubt, you can tell me. So 4 by 4 identity matrix, the number of independent real parameters of A is, okay, so options you're gonna have are 32, next is 10, then it's going to be 12, and the next one is 16. So let me know if in case there is anybody having any doubt, we can talk about it then. But if everything is clear, that's great, great, great. So 4 by 4 complex matrix A satisfies the relation that is A dagger A is equal to 4I, where I is the 4 by 4 identity matrix and the number of independent real parameters of A are. Okay, so that's what you have to find. Now let's go ahead with the discussion. So in this case, first of all, you have to see that are you familiar with some formula which can help you to get the number of independent real parameters of A. Okay, like A is a kind of matrix for which this condition is given to you. So in this case, what will happen? In this case, we are already having A dagger A is equal to 4I. So what I can do, I can consider A is nothing but equal to 2 times the B. Why? Because I want to match the given expression with some standard matrix condition. So for that, I'm just going to show it A is equal to 2B, which will be 4B dagger B, if I'm going to put that A value there, is equal to 4I. So which is going to give you B dagger B is equal to I itself. Done? That's how you can just get it. Now this is the condition for what? The identity matrix. Okay, the unitary matrix, because unitary matrix is the matrix which satisfies this condition and I here is the identity matrix. Okay, now what happens for any unitary matrix for the order n by n, which is the square matrix we will have because its number of rows and the columns are equal in number. So we will have the number of real independent parameters equal to n square. Since A is a 4 by 4 order matrix, the B will also be a 4 by 4 order matrix. And the another thing is, since B is a unitary matrix, the A will also be a unitary matrix. So in that case, the number of real independent parameters in this case will also be equal to n square, which is 4 square, and that gives you 16. Hence your right answer here is option D, which is the correct option. Tell me, if in case you are gonna have any doubt anywhere, we can talk about it, but if everything is clear, I'll be giving you the next question now. Next question is even quite interesting one and is going to provide you an idea that even if there is a question which is new to you and you have not worked on the similar topic, or even sometimes the similar question you have solved, you didn't solve it while doing the preparation, still there are chances that you can solve the questions, you can work on such topic based questions easily. Okay, so that will be possible for you to do. It's going to be the polynomial fx equal to 1 plus 5x plus 3x square is written as linear combination of the legendary polynomials which are going to be like the first expression I'm going to write is P naught x is equal to 1, P1 x is equal to x, P2 x is equal to 1 by 2, 3x square minus 1, as the value of C naught is, that's what you have to find, okay? Now, in this case, the options which are given to you, I'm going to write them here on the side. A is the 1 by 4, B is the 1 by 2, and C option is the 2, and D option is the 4, okay? Now, the polynomial fx is equal to 1 plus 5x plus 3x square is written as linear combination of the legendary polynomials p naught x is equal to 1, p1 x is equal to x, p2 x is equal to 1 by 2, 3x square minus 1, as fx is equal to summation over n cn pn x, the value of c naught is, okay? Now, in this case, what will happen? Firstly, it's very important to understand the question, like what question is trying to say, what information has been provided in the question, and after getting that clearly, we are ready to go ahead to solve it and to consider what steps can be taken to solve it. So the question is the polynomial fx is equal to 1 plus 5x plus 3x square is written as a linear combination of the legendary polynomials which are p naught x, p1 x, p2 x, as fx is equal to summation over n cn pn x. The value of c naught is what? That's what we have to consider. So p naught x I can replace or put at place of 1. P1 x I can place or put at place of x. 3x square can be written as 2 p2x plus 1, but 1 is p naught x. So you are going to get 2 times p naught x plus 5 p1x plus 2 p2x. So 2 times p naught x plus 5 p1x and 2 p2x. So what is the coefficient of p naught x we will have overall after simplifying the expression? That is 2. So this is how our right answer for the coefficient of p naught is 2. And that's your option C, which is the correct one. That's how you're going to get it. Please tell me if in case there is anybody having any doubt, we can talk about it then. But if you're getting it, that's great. One question from the metrics part we will be taking after this. And it's gonna be here. You can tell me if there is anybody having any doubt. So you can see it's more about understanding the question. And if you understand the question in a better way and you are getting what was given, what they're trying to say, the chances of solving the question correctly and getting its right answer will increase. The last one is 1. Okay, try it now and let me know, guys, what will be the right answer according to you. Otherwise, we are just going to start the discussion soon about it. It is one of the eigenvalues of the matrix, that is e to the power a is e to the power small a. Okay, so one eigenvalue is given to you like this for e to the power capital A matrix. But capital A matrix is given to you. So the product of the other two eigenvalues of e to the power capital A matrix will be what? So for this case, what you have to do, you have to find the eigenvalues of normal A matrix. And for that, you will use the equation A minus lambda is equal to 0, the determinant of it. So when you take that, you get the negative lambda here with A, with this 0, negative lambda. Because I is the identity matrix whose principal diagonal elements are 1, you multiply it with lambda, you get the lambda on the principal diagonal elements, and this is how you're just gonna get it. Now the next thing is, once you get the eigenvalues of A, I think you are gonna get A, the eigenvalues you will be having are A and negative A, okay? A and negative A. So it is going to give you e to the power A matrix eigenvalues as e to the power A, e to the power A, and e to the power negative A. So e to the power A as a one matrix was given to you. The product of other two you have to find, which will be e to the power A multiplied with e to the power negative A, which is e to the power 0, and that's giving you 1. Hence your right answer is option D, which is 1. Tell me if in case there is anybody having any doubt, we can talk about it. But if everything is clear, that's great. So we will be keeping it this much right now in this session, guys. We'll be having more important sessions in upcoming days. You all can join them. Even on Unacademy, will be having many new courses starting on Unacademy, which will surely be helping you to take your preparation to the next level under the guidance of top educators. Even now, the notes are available on the learning app, which will be helping you to take your preparation to a very good level. So whenever you will proceed further to take the subscription, you can use and apply the code Anjali A Live as mentioned here on the screen, and you can get the discount in the total subscription amount. This is about the light subscription. This is about the plus iconic and the light subscription. The difference between the different subscriptions have been shown here. So in this case, if there will be anybody having any doubt, you can surely tell me about it. Or otherwise, guys, you can start your preparation under the guidance of top educators. And in upcoming days, so many new courses will be starting. So if you don't want to miss them, you can take your preparation to a very good level then. And whenever you will proceed further to take the subscription, guys, use and apply the code that's Anjali A Live as mentioned here on the screen, and you can get the discount in the total subscription amount.